And we obtained this by proving this theorem. Here again, these make chain of inclusions. That's why they are present as H stabilizer in the graph of group presentation for the congruence subgroups of P1 minus, and also when we translate H with these elements, only H alpha 2 will be present with the corresponding subgroups in the graph of group presentation for P1 minus. Here are some other direction in this which we can extend this word. The congruence subgroups defined in my previous slides, that is only for, we can say for level 1, and similarly for higher level we can define the congruence subgroups for U minus, and similarly for B minus and for P1 minus we can also define the congruence subgroups for higher level. But the graph of groups for the presentation of these congruence subgroups is complicated. Instead of having one ray, there will be core graph consisting of complete bipartite graph. And the first direction is for higher rank at higher level, and the other direction is for higher rank Kac-Moody groups. In our case, it was rank 2. Similarly, we can define the congruence of groups for the higher rank greater than 2. Professor Carbone and Professor Garland in their paper proved that these subgroups U minus, V minus, and P1 minus are also lattices for the higher rank. So we can define, we can obtain, and we can define the congruence of groups in higher rank Kac-Moody groups also. But that is a hard problem to understand, since in rank 2 case we obtained the tree and it was easy, but in higher rank there will be buildings consisting of complexes, and we are trying to work on this in our next project. Thank you very much for your patience.